All right, welcome back. Remember, I am broadcasting from home today because I've got a personal engagement. And remember that my office hours this afternoon and tomorrow are canceled. We are live on Piazza Q&A, but unfortunately, because of bandwidth restrictions, I will not be able to watch on YouTube for any of the chat. So if you've got a question, please make sure that you're putting it on the Piazza Q&A. So today we're going to be talking about encapsulation, and for C that means structures. For Java that's going to mean classes. So let's first briefly talk about the motivation for why we want to talk about encapsulation. Built-in primitive types, such as int, double, or char, right, are very limiting. Right, they're not limited, but they're very limiting. Not everything is a number or a character. Or even if you go on to strings, it's still not a collection of numbers. It's still not a collection of characters. Real-world objects or real-world entities are made up of multiple aspects, right? Multiple pieces of data, basically, right? The classic example that we try to introduce you to is from your lab yesterday. In lab 10, you had to process some file data on Major League Baseball teams, where you had a team name, the number of wins, and the number of losses. And if you took a look at that code in detail, you combine two pieces of data into one slightly less useful piece of data, the win percentage, but you still had these two pieces of data that were stored in two separate arrays. So when you went to sort all the teams by win percentage, that means that you had to sort by one array. But also, if you swapped these two, because they had different win percentages, you swapped the win percentages. You also had to make sure that you swapped the names. In other words, you had to do a lot of bookkeeping. We wrote that code for you, but hopefully you took a look at it and saw, wow, this doesn't look all that great, right? Sorting teams was what you did yesterday in your lab. We kept a lot of different but related data in separate arrays, right? Every swap required the swap of every record in both arrays, right? Not every record, but you know what I mean. The swap. If I'm swapping these two over here, I have to swap these two over here. It's a lot of extra bookkeeping, right? Right. And that was just with two pieces of data. Imagine you had 3, 4, 5, 6. Are you going to want to maintain 6 different arrays where all the data is separated across 6 different arrays? No. It's very inconvenient, right? To separate related pieces of data. All right. So the solution is encapsulation. Right? For C, that means creating what are called structures. Right? And for Java, that means what you've been doing implicitly, but now we're going to do it more from an object-oriented programming perspective. It means that you're going to start creating classes. So what is encapsulation? Encapsulation is a mechanism that allows you to do 3 things. 1, group pieces of data together into one logical unit or entity. That unit, again, in C, it's going to be structures. In Java, it's going to be classes. 2, the protection allows you to protect that data. Protect that data from the outside world. Well, the outside world being outside code. All right? And 3, group functionality that acts on that data with the data. All right? So we're going to take a look at an example through a tutorial session here where we're going to create a structure. We'll just do films. Of course, we have quintessential examples all the time. Yesterday, I think I forget what it was, books. You got anything media, books, films, albums, whatever, people. All these things can be modeled with either a structure or with a class in Java. What we're going to find out, though, is that C only supports weak encapsulation. So C only supports number 1, right? The grouping of data. Technically speaking, C can offer you, through conventions, it can offer you number 2, and it can offer you number 3 through function pointers. We're not there yet. Basically, you have to bend over backwards to get the other 2 aspects of encapsulation out of C, because C is not an object-oriented programming language. Encapsulation is more of an object-oriented programming language concept, and Java, of course, offers all 3 of these things. Java supports all 3, right? So let's just go ahead and get into it with an example, right? What we're going to do is we're going to design a structure that models a film, right? And then, of course, we're going to do the same thing. We're going to design a class that models a film, right? So we're going to do this piecemeal. We're going to design the class. We're going to design the structure, then we'll go over and design the class, and then we'll get more in depth. Of course, we're going to continue next week here as well. But I'm just going to go ahead and jump over here to the CS50 IDE, and we're going to start, right? So I want to create a structure that models a film. So my first solution here is, but the first thing I want to do is I want to create what's called a type def. And this is something you've seen before, type def. You've seen this before when we created enumerated types, right? But now we're not creating an enumerated type, because an enumerated type is a list of values. Instead, we're going to be creating a structure. You don't use the full word structure, you just use struct, right? We need a name for our structure, and so if I'm going to be modeling films, then I will want to call it film, right? I'm not going to call it films. I don't want to pluralize this because it is not the film's structure. Each instance of a film is a film, but if I had films, like multiple ones, and then that would be an appropriate name for, say, an array or something like that. But this is just one of them. Or in fact, it's not even one of them. It's basically just the definition of one of them. It is a blueprint for creating films, or for what films are, right? Now, normally I would go back and forth, and we would, with students in the classroom, and we would ask, what defines a film? Well, first of all, of course, a title, right? And what is that going to be? It's going to be a string, so I'll label it as a char star here. One aside here is that you can create structures with static arrays of characters. So you could put in here a title of length 100, or an array of size 100 of characters. That would work as long as you never have a film with a title more than 99 characters. Remember, 99, because one less, you need that null terminating character. I want to make sure that this is future-proof, and so I will make this into a dynamic character. Okay. What else runs? What else defines a film? Well, maybe a runtime, right? And I chose to do an integer here because you could have hours, minutes, seconds, right? You could break that down. What I'll just do I'll have the runtime in minutes. All right. You could put that as a label as part of your variable name, or you could just have put it in your documentation that represents the number of minutes of the runtime. So 120 minutes for a 2-hour film. Okay. You could also have things like, say, box office. All right. How much money did it earn, right? Or rating, right? And not rating as in PG 13 or PG-13 or R, whatever the ratings are nowadays. But rating as in like the IMDb rating, right? IMDb rating where it's 0 to 10, and of course it's an aggregate, so people can rate this a 9.5 out of 10, right? Or on average. I'm just doing this to show you that you can create structures with all the primitive types here. Right? Here I've got a char star, I've got an integer, I've got a double. And one other thing that I want to do is have a release date. Right? Okay. Now, There are lots of ways of representing dates. Just like there was lots of ways of representing runtime, we could break that down into hours, minutes, seconds, milliseconds if you really wanted to, or a number of frames or something. Now, but dates, there's a little bit more of an argument here for a little bit more thought, right? Now, there are lots of ways of representing a date, right? I could represent this as, say, a string. Today is October 22nd, 2020. It's also oct 22nd. It's also oct 22, right? In other words, we've got a lot of issues. If we're going to model this with a string, we've got a lot of issues as far as formatting. Now, fortunately, there are standard formatting formatting standards for dates. 8601, that's an ISO standard, right? And you can kind of see what it looks like here, right? Over here, that you've got the year, the month, and the date with leading zeros. So if it was May 5th, then it would be 0505, right? If it were October 5th, then it would be 10-05. That's followed by a time with a down to the second. You can also have more accuracy down to, I believe, fractional seconds. And then this is a Greenwich mean offset, right? So there is an ISO standard for defining dates and and times and stuff like that. And not only the way that they've done it here is they've made sure that it's lexicographically orderable. So if you have a bunch of dates, the most significant values are first. So the years, then the months, then the days. That's how you should always do dates anyway, right? The American way of doing it is wrong. The European way of doing it is wrong. An ISO 8601 is the correct way of doing it because when you go to sort dates, now it's lexicographically orderable, right? Rather than some weird, you're going to have to convert like May, or like I wrote before, October 5th, or October 22 with an ND at the end of it. It's just a huge hassle, okay? Don't do it, right? Bring in a library if you're going to do something like that. But I want to illustrate an alternative, right? There's another way of representing dates with a single number, just like we did with runtime up here, right? That's what Unix does. Unix runtime time. Okay. Well, we'll run right directly into the problem here. Basically, they have one number. That number represents the number of seconds since the Unix epoch, which is January 1st, 1970. Negative values, of course, go back in time prior to 1970. The problem here is that if you use one number, a finite number, just like the Y2K problem where you use 2 digits to represent a year, well, what happened in the year 2000? Well, it went back to 1900, right? We're going to have a problem with Unix time for any system that is using a 32-bit signed integer to represent the date. We're going to run out of numbers in 2038, at which point all systems will need to use a 64-bit number, and then we're good for another couple trillion years. But certainly, that's not going to be a problem with any computers today. You have a couple trillion years to update your systems. But here, we only have about 18 years left if you're using a 32-bit signed integer to deal with this. So we could design this to be, kind of a Unix epoch time where we are counting the number of seconds since 1970, right? Whatever the current time is. What I want to do, though, is I want to illustrate what's called composition. A release date is actually a month or a year. It is a month, and it is a day, right? Not date, but date, or day. Like today is the 22nd, so it would be 22. I can represent this using 3 integers. What is that yelling out to you? The whole point of doing encapsulation is that you group related objects or related pieces of data together into one thing, right? These 3 things are related. So what is that yelling out to us? Maybe we want to create another structure here, right? And I'm going to do that now. Type def struct. Right? And I'm going to create a date. Right? Now, this date is more general than just a release date. It's going to have, so I mean, I could have, an actor, a model, an actor, and then they have a birth date. I could have another date for the DVD release or whatever. So I'm going to go ahead and keep this general, but I am going to represent it with 3 numbers: int, year, month, and day. Now there is a drawback to this because there is no way of enforce, or I'm going to have to do all the enforcement of data validation. In other words, if somebody tries to set the month to 13 or the day to 58 or something like that, those are valid integer values. So we're going to have to be very, very careful about something like this. Now, in a programming language like Java, where you have the protection of data from outside code, right? You could protect the data from you could protect the day from ever being set improperly to negative values or 0 or anything above 31. Or if the month is February, then you make sure that it's not set to 30 or 31. Or if it's set to 29, then you have to also check the year because that's a leap year day, right? If we had the protection of data, we could enforce that within the structure itself. Unfortunately, in C, we don't have number 2. We just have to be very, very careful that we're not setting a bad date or anything like that. Once we've defined this, we can start using it. Release date. This is composition. The date structure is composed of 3 primitive types. It's composition, right? But also the film is the film structure has 3 primitive types, and pointers are primitive types technically. But it also owns another structure, right? Let's try to compile this. Let's see what happens. There's an error. It doesn't know what date is. I declared it down here on lines 12 through 16. So, what does that tell you about order? Order matters. I try to use it up here on 9. It better be declared before you use it. Right there. Now order matters, and I've got the correct order now. I can go ahead and compile this, and it's happy. Of course, I'm not actually using my structures yet, but I have at least defined my structures. Okay. So now let's go ahead and make some observations about this, and let me go ahead and bring all this stuff over into the notes so that you have it. All right. So here's my first design of a film for the first part, right? So observations. Let me give myself some more room here so that it snaps up more. Okay. Generally, to define a structure, you use typedef struct, right? Followed by opening and closing curly brackets, opening, closing curly brackets, enclose or encapsulate the variables that belong to the structure. Right? Variables in a structure are known as member variables, or component variables. They go like by a lot of different names. We're going to call them member variables. It is a member of that structure, right? At the end, there are actually a couple of different ways of syntactically creating structures. Each one of them puts the structure in a different namespace. What I've done here is I've put it into the global namespace. I'm just going to go with one to keep it simple, and this is the way that I'm showing you how to do it. Variables in a structure are known as member variables. At the end, you provide the name or the identifier of the structure. Right? By convention, and there are lots of different conventions here. There are classical conventions and stuff like that. I'm showing you a more modern convention. By convention, the name of the structure is upper camel cased. Right? By convention, member variables are lower camel cased. And you saw that with release date and run time. right? IMDb rating. When you've got acronyms like this, you treat them as one word. Right? This is all C so far, right? We have not done any Java yet, right? So don't worry. Here, I'll go ahead and separate example C, right? And then I will separate that out into another example Java. All right, there we go. All right, so we're still talking about C here. Okay. By convention, the member variables are lower camel cased. You use a semicolon at the end of each variable. Right? This is in contrast to type def enum, where it was a enumerated type. It was a list of things, and so how do you give a list? A, comma, B, comma, C. All right. These are actual variable declarations. So you just like a variable declaration in regular code, int x equals 10. Well, you can do initializations like that. I won't get into it though. But you use a semicolon at the end. You also use a semicolon at the end of the name. Right. Order matters. If you have a structure that uses another structure, the declaration must be in order. Right? In fact, by convention, usually structure declarations are placed into header files. Right? So I ultimately I might separate this into film.h file. In fact, let's go ahead and do that. Let's go with a new file. There we go. Film.h. And I can take this stuff and I can move it over into that header file, including film.h. Right. There. And now over here in my demo, I have those definitions, and I can still compile even though I've separated them out. Right? That's because you might want, in fact, you might want to separate this further into a date header file, into a film data file, header file, etc. In fact, you may not even want to use date. There is actually a built-in time date_t that if you bring in I think the time library, I think it's in include time.h, right? There's going to be like a date_t. _t is like old school way of doing things for types, but we won't get into that here. Okay. Usually structure declarations are placed into header files, into separate header files. We say when a structure has an instance of another structure in it, we refer to this as composition. Right? It's composed of other things. It's composed of another structure. Okay. We also, alternatively, we say that a structure owns an instance of another structure. Right? Owns, composition. When we say owns, that means it's also responsible for it. So if it were a dynamically allocated memory, then it's responsible for cleaning it up, basically, or that it owns it. If I've got a film that owns a date and I clean up the film, I need to make sure that I clean up the date as well. Now, in this case, there is no dynamically allocated stuff in date. These are all just primitive types, so we don't actually have to clean up after ourselves here. The only thing that we potentially have to clean up after ourselves with is the title, because that's going to be a dynamically declared string, or dynamically created string. Okay? All right. So, we've not talked about how to use these things yet. Before we do that, let's go ahead and switch gears over to Java and do the exact same thing, but let's do it in Java. Right? For that, I'm going to go ahead. Hopefully I don't have one created already. Nope, I don't have a film class here at all, right? So I'm just going to put this into the default package. Right-click. I'm in Eclipse right now. Right-click and create a new class. I'm going to follow the same conventions. In fact, I've just taken the modern Java conventions and applied them to C here. And I'm going to create a film class here, right? Let me give myself some more room and increase the size for you at home, right? So public class film. I'm following the same conventions that, and in Java these are way far more important conventions. Again, in C there are lots of different other style guides out there, but in Java there's really only one style guide, and so all classes have a upper camel cased name, right? Now, you've been putting methods like public, static, void, main into your classes. Now we're actually going to start putting variables into our classes. Again, these are member variables. So what did I have before over here? I had a title, a runtime, an Internet Movie Database rating, and a release date. What does that look like over here? Well, of course, I don't have char stars. I have strings. I do have integers. I do have doubles. Dates, I can go ahead and create another date class here. New date. Right. But be careful. I'm going to take a little bit different design approach to this one. Over here, I told you that there is, in fact, this date underscore t thing in the time library. We're not. You can use it if you want to, but I'm going to go ahead and over here, I did just a custom date to show you how it works. Over here, I'm actually going to follow a better design principle. I'm going to use the built-in type in Java. And the built-in type for modern Java, I believe Java 8 and beyond, is local date. All right. And we need to bring that in. It's from the java.time library. Local date because it's localized, because of course we are living on a planet here, and different parts of the planet are on different dates at a particular moment in time. So it's all relative. Also, local date time. There's a local date time, right? That you can bring in that has a date and a time. I just want a local date here as the release date, though. Okay. Oops. There we go. I've just indented properly here now. All right. So again, going back to our original notes here, remember what encapsulation is. It's the grouping of pieces of data to act together as one logical unit. All right. That's what I've achieved here. That's what I achieved over here with a structure. It's also what I've achieved here with Java. But number two is the protection of data. Okay. So what I'm going to do is I'm going to protect these pieces of data from the outside world. In other words, if I tried to do something with the code over here and create a film class, right? Film f is equal to I'll just create is equal to new film, right? We're getting into something that we're going to get into eventually here in a second, but let me just go ahead and show you what I can do. F dot let's say runtime, right, is equal to -10. So it's a film that runs for -10 seconds. Does that sound appropriate to you? Probably not, right? In other words, from the outside world, I can go ahead and jump inside of your class and I can start mucking with values directly. And that's because I've not protected these variables. Now I'm going to protect them. I'm going to protect them with the keyword called private, right? And I'm going to type. Okay. All right, here's a trick with Eclipse. I believe that it is. Oh, now, darn it! Now I forget. Actually, darn it. Should be Control A. Control. Nope. I'm gonna have to guess. There we go. So unfortunately, it zoomed out there. But what I'm going to be, I think I've shown this to you before, but this is block selection mode, and I'm going to make them all private at once. All right. And again, you can go into and out of block selection mode with Option Command A. I'm on a Mac though. For Windows users, go ahead and post whatever it is in Piazza for those other Windows users. Now, without a keyword here, there are other alternative keywords. For example, you can have public. Now it's open to the entire public. Any other piece of code can see this variable. Any other piece of code can change this variable's value, right? We don't like that in general because it's like throwing number 2 of the of encapsulation out entirely. Oh, I don't care about protecting my data. Go ahead and set runtime to -10 minutes, right? That's fine with me, right? By making them private, that means that only this class can change its values. In fact, if you go back over here to demo, my attempts to change this to -10 minutes didn't work, right? It's going to say that that's not visible, right? If you can see it down here, that's exactly the error message here that the compiler is giving me, that it is not visible, right? We like encapsulation. We like strong encapsulation. We like the protection of data. I'm going to talk. We're going to eventually get to, well, if there's private, how can you ever set it? We're going to do that through constructors and getters and setters, accessors and mutator methods later on. Okay. Right now, I'm going to protect it. Right. I'm going to go ahead and cut and paste this into the notes, and let's make some more observations about this. Right. Java. There we go. So more observations. Right. Similar naming conventions. Right. Use upper camel casing for class names. Lower camel casing for member variable names. Right. With Java, there is strong encapsulation. You can protect your variables from the outside world. In other words, outside code outside of your class. Right. The keyword public means that any code can see and change your variables. Right. It's like having a global variable, and we all know that globals are evil, right? Because if any part of your code can change this variable, then you need to test for the eventuality that every part of the code will change that value. What are all the side effects to that? Absolute chaos, right? It's very, very difficult to test. It's very, very difficult to localize changes. We like chaos, but we like controlled chaos, right? We like to limit the scope of our variables. We like to limit the scope or the effects of any code that we write, right? Good for block selection mode in Eclipse for Windows. That's going to be Alt-Shift-A. Right? Thank you. So any code can change your variables if they're public, right? It's like essentially having a global variable. Another alternative is protected, right? Protected means that the class and any subclass can see your variables, right? This involves inheritance, which we will not get into in this class, so don't worry about protected for now, right? But do know that it is out there. And then finally, private, right? Only your class can see the variables, right? And in general, make all of your variables private unless there is a very good reason to do so, right? There's hardly ever a very good reason to do so. You can make them public and final, just like the math library does public, final, double, pi, so that, it's public. Anybody can use this value of pi, but by making it final, that means that nobody can change it. Nobody can change pi to 4, right, magically, right? Because we made it final, and any change to it after that is not allowed. The absence of the lack of a keyword, it makes a variable package protected, meaning that any other class in the same package can see your variables, right? So it's somewhere in between, I'd say public and protected, but in fact, let me go ahead and move it up. Right? There we go. Right. So The most open being public, the least open being private, right? Only instances of the variables of that class can see those private variables. And it's a very, very good design to keep everything private and control them through constructors, getters, and setters, which we're going to talk about shortly here. Right? Okay. Great. Now let's switch back to our structure design. Right? So let's talk about using structures. Right? There we go. Right? Using, and eventually classes. Right? So once declared, again, typically in a header file, you can create an instance of a structure naturally. Right? Dot, dot, dot. So what I'm going to do is I'm going to switch back to the CS50 IDE here, go over to demo, and now that I've got that film structure defined up here in the header file, and I'm bringing that header file in, I can go ahead and create a film. F. Right? That's it. F. If you want to give it a title here, I don't know. I don't watch that many movies anymore. And we're too much on a lag here for you to suggest one. I can't remember the last film I saw. Certainly not in a theater for a long time now. But even before COVID, no, it was too expensive. I don't know. What was the best film of 2020 according to critics so far? According to the Rotten Tomatoes or IMDb, I don't know what any of these are. All right, what's the worst film of the year? All right, if there are suggestions online, let me know. But otherwise, let's just go with Apocalypse Now. Okay, so the way that I can access variables inside of my film. Remember, member variables that I've got the title, I've got the runtime, and the IMDb rating, etc. I can use the indirect or the direct component selection operator, which is a period. So title, I can set that equal to Apocalypse Now. I don't even know if that's the correct spelling, but let me pull it up here just to make sure. And we can also look up its IMDb rating. Looks like it was released in 1979. 1979. August 15th, 1979. So we're going to need all that stuff. Now, first of all, can I do something like this? Absolutely not. This is one of the key mistakes that we saw in our Lab 10 from the main section at least. I've got a string on the right-hand side and a string on the left-hand side here. Do you use, in C, do you use the assignment operator to assign strings? No. Right? Instead, what you need to do is you need to use strcpy. Into title, Apocalypse Now. Right? But the problem is, title is nothing more than a char star. So if we're going to copy in Apocalypse Now, that means that we have to also set up memory to take care of it for us. F.title is equal to a call to malloc. Size of char, times how many characters do you want? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Y plus 1 for that null terminating character. Remember, don't forget that. But once we've set up our memory, then we can use strcpy. Then I can go ahead and set the runtime. I don't know, find minutes. Runtime, 147 minutes it says. So f.runtime is equal to 147 minutes. What else do I want to set? The IMDb rating here. Looks like rating 8.4, right? This is actual data. IMDb rating equals 8.4, right? And then finally, the release date here is August 15th, 1970. So f dot release date. Wait a second. That's a structure, right? That's another structure. That gives me a date structure. That date structure also has member variables. So if I've got composition, that this object is composed, or this structure is composed of this structure, the way that I can go, I can get to that structure is through that period operator, that direct component selection operator. And then once I've got 3 components to that, all I need to do is use another period operator, right? Period year equals 1979, f dot release date of the month was August, which is going to be 8, right? And then finally the date was the 15th day. There we go. This is called technically the direct component selection operator. It's just a period. So what does it look like? It's a dot. It's the dot operator, right? Don't worry about calling it the direct component selection operator. It's the dot operator. Don't worry about that, right? But I've now set everything here accordingly. Well, I like multiple films here, so film F2. I'll call this. Now I want another film, say Star Wars, right? Copy, paste, right? And then Star Wars. And I don't need 14 anymore. I only need 9. And the runtime, I don't know what that is, but Star Wars, IMDb. Let's see. Okay, I'm going to get a million things. 1977, of course, it was released. There we go. All right, so May 25th, 1977. May 25th. Or May 25th, 1977. What is its rating? 8.6, right? And its runtime, 121 minutes. All right, that looks good. I want another film. If I keep doing this, you can kind of see copy pasta. Should I be doing that copy pasta? No, right? Let's rethink this. What if I had a function to do something like that for me, right? What if I had a function called create film, right, that took all of the necessary components to create a film? In other words, the title, the runtime, the Internet Movie Database rating, maybe the year, the day of the month, or maybe just an entire date instance. Then I could, have one function to do this all, and I wouldn't need to copy paste this entire 10 lines or whatever it is every single time. Let's go ahead and write that. Right? So I'm going to take in a char star title, right? A runtime, right? An IMDb rating, which is a double, right? And let's just go ahead and take in a date, a release date. Right, there we go. We'll keep it simple. Now, what's its return type going to be? It could be a film, right? In which case, that's going to be essentially be static. It's going to statically create this on the call stack. It will work if I set f equal to create film. But the way that it will work, it will copy this thing on the call stack to the return call address. And then that will then be copied again to the local variable that I assign it to, right? That'll work. It's basically under the hood. It's doing it's doing a CPY memory copy, and it's copying this chunk of memory of statically declared memory here. It'll work, but I don't want that design. I want this to be returning a pointer to a film. Okay, so let's make our documentation here. This dynamically creates a new film instance from the given data and returns a pointer to it. Right? Everything will be dynamically created here. All right? So I'm going to go ahead and I'm going to have to create now a film.c file. Open that up. Make sure that you are including the film.h header file for that prototype that I just created. And let's go ahead and actually write this now. There we go. By the way, if you've got long lines like this, then you can go ahead and go to the next line, go to the next line. You can align them all as well if you really want to. I wonder what A-style would do with this. A-style film.c. Ah, there we go. It did my work for me. It aligned everything up right here. Nice. So how do we create this film? How do we create anything that is dynamically created? We need to call malloc, right? So film f star f, right? Because we do need to return a pointer, right? And we're going to make a call to malloc, right? Film star, right? And a call to malloc, right? We are casting this as a film star because it is a film star, right? Not film star as in the actors, but film star as in a pointer. Now, how many bytes do you want? Well, if I go over here to film, I see, oh, there's a pointer, that's probably 8. There's an integer, that's another 4. Doubles are 8, so I'm up to 20 now. A date is another structure, which contains 1, 2, 3, 4 integers. Okay, that's 12 additional bytes. And now I've lost count anyway. It doesn't really matter. What did we do when we created an array of integers? We let the compiler do that adding for us. Size of film, right? You can still use size of even on user-defined types because compilers are dumb, but at least they're smart enough to go and say, oh, that's 4 bytes, that's 4 bytes, that's 8 bytes, and I can add that up for you, no problem. How many do you want? I just want 1. Right? This is not an array. I mean, technically it's an array. It's an array of size 1. This, strictly speaking, is not necessary, but I am doing this in the demonstration here so that it drives home the point that this is actually only one film. This is not an array of films. If you wanted an array of films, okay, there are 5 films here, right? And it's exactly the same type here. It's just that then you start indexing them, right? We'll talk about arrays of structures later on. Okay. Now, f dot title. Let me go ahead and just actually grab my code from over here and adapt it. F dot title is equal to blah, blah, blah. Now it's not 14, but it's going to be whatever the title you were given here, strlen of title. Right? And if we're going to be using the string library, we'd better make sure to include it. Also include the standard lib while we're at it. And if we eventually do some I/O, then standard input-output library. We'll get there eventually, though. Okay. That gives me pause here. Am I going to be making any changes to that title? Probably not, right? In fact, I don't want changes to the original title. I'm making a deep copy of that title right here. So, make it const. Okay? You don't have to make integers and doubles consts because they're passed by a value. So even if you change the value, you're not changing the original value anyway. Okay? Likewise with date. It's being passed statically here. It's being passed by value. Copies of those 3 variables are copied onto the program stack, and you receive copies of the year, month, and day. Okay? But otherwise, that looks good. Now, instead of copying Apocalypse Now and hard-coding that, then it's title. Right? Instead of that, it's runtime. Instead of 8.4, it's whatever you were given as the Internet Movie Database. And instead of this, it's release date. It's going to be f.release. Release date is equal to release date. Right? Of course, we could have broken that down up here into 3 components and then had the original. This is not going to compile. Compile film.c. Right? The error is all over the place here, but it's the same error. F is a pointer, film star. Did you mean to use something else? You cannot use the direct component selection operator because you have a pointer here. The solution to that is to go ahead and dereference F. Once you've done that, then you can go ahead and use the direct component selection operator. The problem is that the direct component selection operator has a higher order of precedence than the dereferencing here. What I've done is I've taken, I'm trying to dereference this to take the pointer and make it into a regular old variable so that I can use the dot operator. Right. So what I have to do is put that in parentheses. Now it's been dereferenced, and I can use the direct component selection operator, the dot operator. Right. That's so tedious that, as per the suggestion of the compiler here, there's another way of doing this syntactically. That's the indirect component selection operator, where it automatically dereferences it and then applies a direct component selection dot operator for you. But what does it look like? It looks like an arrow, so we call it the arrow operator, right? And that's what I'm going to do for the rest of all of these. Right? If you have a pointer to a structure, you use the arrow operator. If you have a regular old structure, you use the dot operator. That looks a lot better. Let's try it. Ooh. Did I do it wrong? Nope, that looks good. Was here conflicting types. Create film. Oh, you know what? I changed it to const here, and I should have changed it to const here as well. Sorry. There we go. Now we're fine. Right. Let's check. Should we start using private classes in our assignment if we want? You can if you want to. Yeah, sure. We could. I don't know if Cats was released this year or not, but we could definitely use that as an example as well. IMDb Cats. Now you've piqued my interest here. What is its rating? Oh, 2.8. So I don't think that's the lowest rated IMDb score ever. I really wonder what major film would have the lowest score ever, but I don't know. So let's go ahead and create a film here, and I'm going to call that function that I just created, create film, right? Equals to create film, and instead of having to do this every single time, now I can go ahead and go with Apocalypse Now 147 8.4. And then I do need to create a date here, unfortunately, because of the way that I've designed this. But of course, what I could do is I could go back and create a create date, right? D, and D is dot release year is equal to 1979. D dot month is equal to 8. D dot day is equal to 15. I could create my own, but I want to show you some special syntax here, right? Right. 4 lines just to create a date. For my second version here, this is F1. For my second version, I'm going to do something a bit different. Date D2 is going to be equal to 1979, comma 8, comma 15. I'm doing this off the top of my head, so let's make sure that this is actually valid. It will go to the order matters here. So if you declared it year, month, day, then that's the order that you have to provide using this syntax, this curly bracket syntax. Okay, is equal to create film, and then here we want Star Wars 121 8.6 and D2. And just for fun, let's go ahead and make that other film. D3 is equal to, let's see. It was 2019, sorry. It was 2019, December 20th. So that doesn't technically count this year, right? And then film 3, Cats. I don't know. I've not seen it. 1 hour and 50 minutes, so that would be 110 minutes. And then what did I say? It was 2.8. Yeah. And then this will be D3. All right. And let's see if this all works. So, of course, we didn't make any changes to our header or source file. So gcc film.o and demo.o. Yep, all right, it all works. Of course, if I run it, it's not doing anything. It's just creating these objects and then ending the program, right? So what I want to do next is I want to actually start working with these things and maybe printing them out or something like that. But before we do that, let's go ahead and review what we've done here in Java. How would we do the same thing, right? In Java, it's a little bit different. You actually have what's called a constructor. A constructor is a method that usually they're public, but you can make them private. We'll go ahead and make all of our constructors public. You can make methods public, private, or protected as well to protect them from the outside world, so that the outside world can't call your constructor. But what a constructor is it has no return type. Usually you have a return type of void or int or double, right? There is no return type, and it has the same name as the class, right? It's a very special type of method, the constructor method, because the syntax is you don't have a return type. Implicitly, it returns an instance of film already. It has to have the same name as this one up here, because if we have a different name, films, now this is no longer a constructor. And you do need a return type for non-constructor kind of methods. So it has to have the same name, and then it can take any number of arguments here. In this case, I want a string title, an int runtime, double IMDb rating, and a date, a local date, release date. Right? Lots of typing, lots of typing. I hate typing. Right? Let me make it not so big, or give myself some more room. Right? There we go. Or you can go down to the next line if you really want. Next line. Correct that. Next line. Right? And but when it auto formats it, it goes back for you. Oh well. So what? So title, like we did before, is equal to title. I don't have to do char star here. I don't have to call malloc or anything like that, because strings are nearly first-class citizens in Java. Runtime is equal to runtime. IMDb rating is equal to IMDb rating. And release date is equal to release date. Lots of typing. I hate this. Not only that, but now I've got a lot of warnings. I wonder what those are. Let's hover over here. The assignment to a variable has no effect. You have to be careful here. Over here in the C version, when I did this, there is a parameter called title, and the film itself has a variable called title. So there are two variables here called title. But since I was doing F and then the arrow operator, it knew that this title referred to the film's title. If I just had title, then it referred to the parameter title. Over here in Java, I've got two variables named title. I've got the member variable over here, which is called title, and I've got the parameter variable over here, which is called title. Without any other further qualifications, it always refers to this title right here. In other words, I'm just resetting this title right here to itself again. The complaint here about that the compiler is giving me is that it's something like this. X is equal to 42, X is equal to X. This line right here has no effect. It'll compile, but it'll be a warning because, again, the same warning here, the assignment to the variable X has no effect. You're just taking it and putting it back into itself. You're taking the value of the title, Apocalypse Now, and you're putting it back into itself. How do we refer to this variable, the member variable up here, versus this variable right here? We need a way to disambiguate this. Okay, in fact, that's what we use. This dot, right? And hey, dot, that's the direct component selection operator used in Java as well. You've seen it before, of course, up here with used in the context of packages. Java .time .local date. It's a way of delineating things. It's a way of, well, this object's title, that object's title, that film's title, that film's title, right? In this case, we're using the this. Now, over here in demo, when I create a film, don't worry about the syntax errors here. When I create a film, in fact, I'll just do it like this. This film instance, this variable has a name. Its name is called F, right? I could have my favorite film. I could call it my favorite film instead, right? That's the variable's name. If I want to refer to that film, I would use the variable's name because it's named, right? It has a name, my favorite film, or F, as it was before. Over here, do you see a name for this film? No. A class is only a blueprint. How do I refer to? I'm inside this method right here. How do I refer to my title? Right? If I am this object right now, oh, I don't. I need a way to refer to myself. Right? Now, as humans, we use me, myself, and I. And some programming languages actually use me or self or things like that. But this is just an object. It's not a person. So we treat it like an object. This, not me. I don't have an I'm the class now. I'm not a person. So I'm going to refer to myself as this object, right? This dot title. And now all those errors will be resolved. This title is set to that title, right? Again, to drive home the point that there are different variables, I could have done this. I could have said title is equal to t as long as I gave the parameter variable a different name, right? But that's not what I chose to do. I chose to make it title so that I would remember I need to set this title to that title, this title to that title, right? Do not do something like this. This is very bad. Right? That title, no. Right? So like I said, I've got lots and lots and lots of typing there. Oops, undid it all. Right? What you won't see it on my screen here, but if you go up to in your Eclipse, if you go up to source, you can go down to generate constructor using fields, and a dialog like this will pop up. You can create a constructor based on all four of these things, like I just did in the demonstration. Or you can unclick them, and I only want a constructor that sets the title and the rating. I don't care about runtime or release date. I'll take care of those later for some reason, right? When I generate this, it writes the code for me. Awesome. Don't worry about this super here. If you want another constructor, like the one that I just wrote, right, then generate constructor using fields. Make sure that you select all and generate. Right? That's pretty much what I did already. Right? That's exactly what I wrote before. But I didn't have to type a single line of code. My fingers are now thanking me. Right? So that's a really nice, easy way to leverage your IDE for less typing. And I'll show you tricks like that later on as well. Some languages actually build this in. In fact, the latest Java version 15 or 16, maybe 16 is not out yet, it has syntax that allows you to create getters, setters, and maybe even constructors syntactically without having to actually generate this code. It's something that some people wanted for a long time that's been in other languages like C#. I don't really care because I know how to use my IDE. The people that want that stuff probably don't know how to use their IDEs properly to auto-generate this code. But you can have multiple constructors here. And now over here, when I create a new film, right? We've seen the new keyword before when we created files, when we created scanners, etc. I can create a new film. Which constructor does it call? It depends on the values that I give it. If I only gave it cats and 2.8, then it would end up calling that 2-argument constructor. If I gave it cats, the runtime, which is, I don't even really care, I think it's 110, right? 110 minutes, and then the release date. Oh, here. How do I create a local date? Right? I could go with new local date of, say, 2019. What was it? December 20th. So 12/20, right? That's using a constructor right there. Let me pull this in. It's still not going to work, though. They took a different design approach here. They made all their constructors private. If I make mine private, then you're no longer allowed to... I'll just put in null here so it actually compiles for a second. And let's get rid of this. Right? I'm no longer allowed to call this constructor. You invoke a constructor with new, but if it's private, then you can't see it. Right? I could, of course, go back to just cats and the Internet Movie Database rating, because that constructor is still public, right? By the way, another trick here, if you want to go to the actual code, at least in Mac, it's going to be hold down Command and then things become clickable and you can go to it. If you ever need to go back, there are arrow keys up here that you can go back to where you came from, or forward. It's just like a browser, forward and backwards, and you can click on stuff. But to click on stuff, you have to hold down the command key. Probably it's going to be the shift or the control key in Windows, but I'm not sure. Again, you can go ahead and post on that on the Q&A in Piazza. So Katzen, according to online here, it's the 25th lowest rated movie. With I assume significant ratings, because there are probably terrible movies that nobody's ever even seen. Mystery Science Theater 3000 style movies that nobody cares enough about to even to rate on IMDb. Right? But anyway, back to what I was talking about before here. Local date. Let me import that. You can't call it constructors because they took a design decision of making all of their constructors private so that you can't invoke them. Right? The way they wanted more control over how you actually create local dates. So they provided a bunch of static functions that will allow you, methods that allow you to do this. Oops, I can't call it local date. I need to call it D, right? And then there's 110 minutes, and then D. There we go. And again, it's not public. I'll make it public. There we go. And now everything is satisfied over here. They have a constructor. This is kind of a, we didn't call it these, but that's what they are. Over here, this create film in C is kind of called a factory function because it manufactures film instances. It's not a constructor because in C, where it's not an object-oriented programming language, it doesn't have constructors. But over here in Java, these are constructors, right? But you can also have factory functions like of, local date of. In fact, I'm not even sure what it calls it. Obtains an instance of local date from year, date, and month. Blah, blah, blah. Nope. Okay. It doesn't call it a factory function, but it is a static function that basically constructs a date for you and then returns it back to you. It's just another way of designing. These are called creational patterns. How can you create objects? Well, you can create them through constructors. You can create them through factory methods. That you can create them through what's called a singleton pattern. There are lots of different ways of creating these things that we will not get into. I'm only showing you the basics for now. All you need is constructors for now. Okay. All right. So that brings us to even even here, using structures, using basic classes. When we come back on Tuesday, we'll of course pick it up from here and make the observations of what we've been doing for the last 20 minutes here. But let's go ahead and take any last questions here. Looks like there's a question related to the homework that I'll take offline. Okay. All right. Excellent. Only 0.3% dropped frames, so my bandwidth held. I never slowed down. Great. I'll see you on Tuesday. Again, from Tuesday on, I will be back in LPH. That's Louise Pound Hall. Right. Have a good weekend. And make sure that you're getting homework 4 done as soon as possible. Do not wait till the last minute. Hopefully you've gotten a significant chunk of it done already. Make sure that you're testing locally. Make sure that you're rigorously testing locally. Because the web grader, if there's a segmentation fault, it's not going to tell you where it is. All right. Good luck.